And share the screen. Okay, so time-wise, we're okay. We only have 3 sections. So I'll do some more of 5.3, and then we'll stop and take a quiz. And then that'll be it for the weekend. Okay, so Monday, I'll finish 5.3 and start some of 5.4. So I have plenty of time. So if I finish 5.3 on Monday, I have maybe 2.5 days to do 5.4. Thursday, questions and answers, and Friday's the test. Okay. So we are here. I've done some of 5.3. I'll do some more. I won't finish it. I want to give you plenty of time to do the quiz, which is on 5.2 material. I think you should find this quiz not to be that much of a problem at all. Okay. Just to let you know, 5.4 is all word problems, though, so we want to spend a lot of time with that. And it's very calculator dependent. So next week, have your calculator handy, if you would. We'll be doing a lot of exponents. And we'll be using the e to the x button and ln button a lot. Okay, so get used to e to the x and ln. They're normally next to each other. Okay, so we'll be doing a lot of stuff with that for next week. So, I mean, yeah, you can just take notes or just watch the video and watch what I do. But of course, you don't just want to take my word for it. You want to be able to punch it in your own calculator that you're getting the same answers that I'm getting. Because when it comes to the test, that's what you have to do. So you'll be using a lot of the e to the x and ln buttons, just to let you know. Okay, so on to 5.3, of which I've already done some. So I'll do some more, and then after a while I'll stop and give you the quiz. And as usual, I'll break you into your breakout groups. If your breakout group ends up with too few people, I might move you. And you have the whole weekend, and it isn't due until class starts on Monday as usual, 9:10. Okay. All right, so continuing on with 5.3. Okay, so we did a lot of this stuff. So I'll do some more of this. And then we have some log combining, where we kind of go backwards. I'll show you some of those. And then some log equations. So how do you do log equations? I'll hold off on the graphs. At the very end, they've got some graphs there, like 55 and on. I'll save that for Monday. Okay, so I'm going to try to do some more of these things here. Do some of these. And then some of these. Okay, and I don't know why this thing turns yellow on me sometimes, but that's the way it is. Okay. All right, so let me do 25. It looks bad because there's a square root inside a square root. 25, kind of messy or even scary. Square root and another square root. Okay. But if you stop and think about it, I mean, just kind of look at one at a time. Sometimes I have the attitude, if you don't like looking at something, don't look at it. See, I don't like square root inside square root. Well, don't look at it. Just look at this, right? If I only look at that, then I say, okay, that means blah, blah, blah raised to the 1/2 power. Okay, so it's going to be something to the 1/2. Okay, so this square root, I don't have any hands anymore, but this square root right here matches that 1/2 power. Okay, so this square root matches that half. So what am I taking the square root of? X radical x plus 1. So there it is. X radical x plus 1 means x plus 1 to the half. Okay, so this is the square root inside the square root. Okay, so one more time. This square root is that half. This square root is that half. And now I have a property of exponent that says if you have something like this, something times something to the 1/2, you can distribute the half. So that half can go here, and the half can go here also. So I have x to the half, x plus 1 to the half to the half. So I'm allowed to multiply these. So 1/2 times 1/2 is 1/4. So I now have x to the 1/2 times x plus 1 to the 1/4. Okay, now it's something I can deal with. So ln of a product, ln of something times something, ln of the first plus ln of the second. And now we know how to deal with these 1/2 and 1/4. 1/2 comes down in front, 1/4 comes down in front. So there we go, 1/2 ln x plus 1/4 ln of x plus 1. Okay, so that's how to deal with that kind of a problem. So it wasn't so bad after all. If you stop and realize, right, say I got too many square roots. Okay, that square root, make it into a half, make that one into a half, and then it's not so bad, right? So that's why there's two halves in there, right? That bigger square root is that one, and the smallest square root is that one. Okay. All right, so that takes care of that. Now, 27 to 32, they want you to go the other way. Rewrite as a single log. So we're going backwards now. Okay, so now take all the coefficients, like 2 1/2 and 1/3, make them climb back up, bring them back upstairs, and then take care of the plus and minuses. Pluses are products and minuses are quotients. So bring it together. So we're doing the exact opposite of this, that's all. Okay, so again, all of these laws, that's what I mean by all these laws are both directions on page 298, right? So even though they write it like that, you might go from left to right, but you might go this way also, right to left. Okay, so you have to be ready to go both directions. So now these problems, we're going from right to left. They're going to start off with a plus or minus or coefficient, and we kind of go in this direction now. Okay. All right. Okay, 27. Whoops. ln x plus 2 ln x plus 1. Okay, this doesn't have any coefficients, so don't worry about it. 2 climbs back up. Leave that alone, ln x plus 1 squared. And now there's a plus. So what happens if there's plus? You multiply these. So ln x times x plus 1 squared. And that's my answer. Okay, yeah. So please notice this is the exact opposite of what we were doing over here, right? Over here we were going the other direction, breaking it up. Now we're going to make it go back as a single log, right? So coefficients climb back up. Pluses means multiply. Minus means divides. Okay, I'll show you those. Okay, 31. ln x minus 1. 1/2 ln x minus 2 ln x. Okay, so all the coefficients climb back up. This doesn't have a coefficient. 1/2 climbs up to there. 2 climbs up to there, right? Like this. So leave that alone. X to the 1/2 x squared. Okay, there's a plus. Multiply. There's a minus. Divide. You put it all together. And x to the 1/2 means square root. So write it as a square root. So x minus 1. And since this is a plus, times radical x. And since this is a minus, divided by x squared. Okay, so that's the way you do these kind of problems. Okay. All right, there we go. So I'm done with what I was going to show you here. Now I'll do some of these log equations, and then I'll stop. I won't do any of these. I'll save these again for Monday. I have time. So Monday, I'll finish the rest of 5.3 and begin 5.4, the last section, which is all word problems. But we'll see how it goes. Okay, the best way to solve these equations is to unscramble it, so to speak. Get rid of the log. Okay, so get rid of the log whenever possible. Something else to keep in mind, the bases always have to be positive. So when I'm solving for like 37, the base has to be positive. Other thing to remember is you can only take the log of positive quantities. Okay, so if you end up taking the log of a negative quantity, you have to throw that out. Something to keep in mind. Okay, so I'll do some of those and then that'll be it. Okay, 33, log base 3 of x equals 4. So unscramble it. I'll say unscrambled. That's not an official math word, but you get it. Okay, write it without the log. So from these 3 elements, I always start with the base. Which of these is the base? 3. Then which is the exponent? The exponent's always by itself. You go on the other side of the equal sign for the exponent, and you come back in for the result. That's what this little mark mean. So it's 3 to the 4th power equals x. So x is equal to 81. So I unscramble the log. I didn't even spell unscramble right, but anyway, unscramble the log. Okay, so you say, I don't like logs. No, I don't like them either, so get rid of them when possible. Right? You see this log, oh, I don't want the log. That's what we're supposed to do, get rid of the log. Okay, so here's 35. Log base 2, 3x minus 4 equals 3. Get rid of the log. Write it without logs. So there are 3 elements, this thing, and this thing. Which is considered the base? The base is always the thing that's sunken down next to the g. So it's 2. Go across the equal sign for the exponent. So 2 to the 3rd, come back in for the result, 3x minus 4. And now this is pretty ordinary. Okay, 2 cubed is 8. And yeah, if you're like me, once you get to this spot, you breathe a sigh of relief, right? Whew, that's easy. I know what to do now, right? So add 4 and divide by 3, x equals 4. Okay, I will say one other thing. You do have to watch out a little bit. Now, if I plug in 4, 3 times 4, it's a positive quantity. But let's pretend x came out to be 0. You can't stop there. If I put 0, 3 times 0 is 0, minus 4, I'd be taking the log of a negative number, and that's not allowed. Okay, in which case I would say no solution. So you do have to watch out for that. Okay, 37. Log base x of 4 equals 2. Unscramble it. Base x, exponent 2, square it. Come back in for the result, 4. X squared is 4, square root property. Normally you would say plus or minus. If you want to know what that is, it's a plus and a minus, but I cross off the minus. Okay, the basis for log equations are always positive, so never mind about the negative. X is just equal to 2, no negative 2. Okay. Then, what do I do if I have an ln or an e? Okay, so I got some stuff involving e and ln. Okay, so to knock out an ln, you put an e, and vice versa. How you knock out an e, you ln. So e and ln always cancel each other out. Okay. And let me see if I can show you that in the text. I showed it to you before. Not sure if it's worth taking time to find it for you. Well, it's a variation of this. Okay. So log base a of a to the y is y. A to the log base a of x is x. So ln and e are a variation of that. Ln is a log. So ln of e to the something, they cancel out. Likewise, you have e to the ln of something, they cancel out. Okay, so that means, how do I solve this? Ln 2 minus x equals 4. So to knock out that ln, you put an e, and the way you put the e is a little bit funny. You have to sink it down into the left, because we like e raised to something. Okay? So yeah, you put the e on both sides, but you don't put it in front. You don't divide by it. You bring it down into the left. Okay, so this is the proper way to write it. Okay, so you sink it down to the left, e like that. These cancel out, so you have e to the 4th power. Okay, so 2 minus x equals e to the 4th. Subtract 2. Negative x is e to the 4th minus 2. And then just multiply both sides by negative 1. Negative 1 times that, negative 1 times that. Negative 1 times that, you just turn it around. So x is 2 minus e to the 4th. And again, present exact answers. Exact answer means leave e as e, leave ln as ln, leave pi as pi, leave square root as square root. Okay, you can give a decimal approximation after that if you wish. So you punch that in your calculator, I got negative 52.60, but you want to give the exact answer. Now, I don't mind that you show this also, but whenever you have a chance, show the exact answer. In other words, I would not accept it if you only showed me this. Okay, I need to see the exact value. This is only a rounding off. And by the way, you should know squiggly equal, right? Squiggly you need approximately. Okay. 43. 2 ln x, ln 4x plus 6 minus ln 2. Okay, same thing. I'm going to get rid of the ln. So make that 2 climb back up. Ln x squared. Aha. I have ln of something minus ln of something. I have a difference, which means I divide here. Ln of 4x plus 6 divided by 2. And now, right, so I have ln x squared, that 2 climbs up. This becomes a quotient, 4x plus 6 divided by 2. And now how do you get rid of the ln's? You exponentiate. The e's go down here. And then you cancel them out. So again, don't divide by ln. That's not the way it works. Okay, you put an e here, put an e here. So e and ln cancel out. So you have x squared equals, and yeah, now you divide, that's 2x plus 3. And now you have a simple quadratic equation. So minus 2x minus 3. Factor x minus 3, x plus 1. X is 3 and negative 1, but negative 1, let's see, negative 1 is not allowed, right? You can't take the element of negative 1. So cross that out. 3, if I plug in 3, everything is positive. So we only keep the 3. So again, you can only take the log of positive quantities. Okay, so if we get negative, throw it out. Okay, 45. ln this minus ln that equals ln 5. Okay, I see a minus sign. Divide. ln 2x minus 1 over x minus 1. Okay, so ln this, ln that. How do I get rid of the ln's? Exponentiate, put an e, put an e. These cancel out. And I have no more e's or ln's. That's what I like. Right? 2x minus 1 over x minus 1 equals 5. Solve that. So multiply both sides by x minus 1. Cancels out. 2x minus 1 equals 5x minus 5. Okay, so that should be pretty easy. Right? So subtract 2x on both sides. While I'm at it, add 5. So I want the x's on the right side and numbers on this side. So I subtract 2x, and while I'm at it, I'll add 5 to both sides. Might as well do it all at the same time. So let's see. 4 equals 3x. So x is 4/3. That's my solution. And quick double check, if I plug in 4/3, I only have positive quantities, right? 4/3. Yeah, we're good. So just leave it, 4/3. Okay, 47, that's an x there. Sorry, the first time I did it, I didn't have an x. It's supposed to be x. 47. (17x). So I snuck in a 17x there. There's an x, there's an x. Okay, sorry about that. Log base 3 of blah, blah, blah. Okay, I don't want the log. Get rid of the log. So how do I write the same thing without the log? Start with the base, 3. Where's the exponent? All by itself on the other side of the equal, 3 squared. Come back in for the result. Okay, and there it is. No more log, no more exponential. Okay, that's equal to 9. Subtract 9. 2x squared plus 17x minus 9 equals 0. Okay, I didn't feel like factoring it. I use a quadratic formula. A is 2, B is 17, C is negative 9. So x is negative b plus or minus the square root of b squared. 17 squared is 289 minus 4ac. 4 times 2 times negative 9. That gives me a double negative. So double negative makes it positive. Scratch paper, 289 plus 4 times 2 is 8. 8 times 9 is 72. 289 plus 72, 361. Over 2a, 2 times 2 is 4. Very conveniently, the square root of 361 is 19. So I have two nice solutions, so to speak. Okay, so negative 17 minus 19 is negative 36. Negative 36 divided by 4 is negative 9. And negative 17 plus 19 is 2. 2 divided by 4 is 1/2. Okay. Now you say, what about the negative 9? It actually works. The negative 9 is not really the issue. After you plug in negative 9, if this quantity, the whole thing inside the parentheses, is negative, I can't do it. But if you plug in negative 9 squared is 81. 81 times 2 is 162. 17 times negative 9 is 153. Believe it or not, this is positive. So I keep the negative 9. And I keep a half. Half is clearly going to be positive. Okay. So I don't draw the negative 9 just because it's negative. It's when you plug in negative 9, and then the result of this whole calculation, if it comes out negative, then I throw it out. But after I plug in negative 9, it's still positive. So I keep it. Okay, then finally a couple of problems here, and then I'll be done. 4 to the x equals 3. Okay, so to solve that, you take the log of both sides. Okay, and we'll be using that theme quite a bit in section 4, the last section of this chapter. So 4 to the x equals 3. Okay, take the log of both sides, ln, ln. Once you have the ln, x can come down in front. X ln 4 equals ln 3. Divide both sides by ln 4. Okay, so x is ln 3 divided by ln 4. Punch it in the calculator, right? 0.7925 approximately. Okay, in case you're wondering, you have to take it exactly like this. You might say, can I cancel the ln's? 3/4. I'll ask you, is 3/4 the same as that? What's 3/4 as a decimal? 0.75. Kind of close, but not exactly. Okay, so you can't do that. The other thing you cannot do is say, can I do ln of 3/4? Okay, you can't do that either. If you try ln of 3/4, you're not going to get that either. Okay. So when you see this, you might want to think, is there any shortcut? The answer is no. So don't cancel the ln's. Don't try to make it ln of 3/4. Just take it literally as it is, ln of 3 divided by ln of 4. And remember, on some of your calculators, you have to go backwards. You have to hit 3 ln divided by 4 ln equals. Okay. All right, and then 51, and I'm done. What time is it? 9:35. Yeah, I think we're good. So 51 is the last one I was going to do. So you should be good up to 53. So Monday, I'll start off with 55 and do the rest of those kind of problems. So I'll be done in a few minutes. If you have a question, you can bring it up, but I do need to give you time to do the quiz. Here's the original. E to the 2x equals 3 to the x minus 4. How do I get those exponents down? ln, ln, ln. Fortunately, this ln and e are next to each other. They just cancel out. Cross them out, 2x. X minus 4, ln 3. Okay, solve for x. So I distribute x ln 3 minus 4 ln 3. Okay, get all the x's together. So subtract this. 2x minus x ln 3 equals negative 4 natural log of 3. ln stands for natural log again. Log natural. Factor out the x parentheses 2 minus ln 3 equals a negative 4 ln 3. And just divide both sides by this, and you've isolated the x. Okay, so x, so again, give the exact value. This is considered the exact value. Negative 4 ln 3 divided by 2 minus ln 3. Okay, so show me that. And then if you want to do a decimal approximation, you can. I did it before. Save time, I can tell you what I got. Negative 4.8752. But yeah, you check this out later to make sure you can get this on your calculator. Negative 4 ln 3 over 2 minus ln 3. And there we go. Okay, and that's about it. And now I'll stop and go on to the quiz. unless you have a question. So let me stop the share a moment, check the chat. Nothing in the chat. Okay, so does anybody want to ask a quick question? Otherwise, we'll go straight to the quiz. All right, so quiz time, that'll do it. So everybody get your cell phone cameras out. As usual, I'll show it to you. You can get started on it. I'll put you in your breakout rooms. And you can work on your breakout rooms until 10 o'clock. And it's not due until class on Monday. You can work it over the weekend. Okay, so here we go. All right. Okay, so there it is. Graph each of the following functions. Now, I'll leave it up to you. You may put them on the same coordinate system or separate ones. That's up to you. Okay, but label which graph is which. So maybe label them 1, 2, 3, 4, 5, or something like that. Okay, and by the way, we're still recording, so worst comes to worst, if you can't get it, it should still be in recording. So e to the x, negative e to the x, 2 e to the x, negative 2 e to the x, e to the x minus 1 plus 2. So it's up to you. You can put them all in the same graph, although it get kind of crowded. Or you can put 5 different graphs, or maybe you can put 2 of them together. Like you want to put 1 and 2 together, and 3 and 4 together, and 5 separate. That's completely up to you. But you must label which is which. So when you graph it, put, or circle, this is 1, this is 2, this is 3, this is 4, this is 5, and so on. Okay. All right, I'm going to assume everybody has it now, so I'll stop the share and set up your breakout rooms. Okay? And if your breakout room ever gets too few people, I'll move you to another